If you look at most of the AI demos today, agents look like the perfect personal assistants. They book flights, buy groceries, and summarize meetings. Those are cool tricks, but they are completely disconnected from enterprise reality. In a Fortune 500 environment, we aren't automating pizza delivery. We are automating complex, highly regulated core business processes. When we design a technical architecture for an agentic system in the enterprise, it's not just about getting a task done. It's about reliability, security, accountability, and cost. So how do we design a multi-agent system that actually guarantees security and reliability? Imagine that a bank's loan officer receives a massive, messy dossier for a client requesting a $10 million business loan. We're talking dozens of PDF files, dense financial spreadsheets, email threads, and phone transcripts. The officer uploads this mountain of data into the bank's processing platform. Before an AI reasoning even begins, the data hits a perception layer. Think of it as an AI firewall. A robust sanitization engine inspects the documents for malware, scrubs out sensitive personally identifiable information, and verifies that no critical legal documents are missing. Once verified, the dossier is handed to an orchestrator agent. This is the manager. Its job is to set a goal, break it down into steps, coordinate and delegate tasks to a fleet of specialized worker agents. The orchestrator sends the massive financial spreadsheets to a data extraction agent running on a fast, cheap model. Its goal is to find and extract the important financial data from the documents. In parallel, the orchestrator sends the complex legal PDF documents to a risk assessment agent powered by an advanced heavy reasoning model. To function as a coordinated team, these agents need a shared brain. As the data extraction agent pulls the client's revenue numbers, it instantly updates the system's short-term memory. The risk agent immediately sees that data and uses it. At the exact same time, it executes a RAG retrieval against the bank's long-term vector memory to pull the specific lending guidelines required to evaluate these exact numbers. But what if the AI needs outside information? Let's say a compliance agent needs to verify the business's corporate registry status. It reaches out to an external API through an action layer standardized by the Model Context Protocol. The agent requests a temporary access token from the Identity and Access Management System. The token mirrors the exact permissions of the human loan officer. The agent is acting on his behalf, and when the API call is done, the token is revoked. To keep all of this safe, the entire system is wrapped in a governance and observability layers. Every tool call, memory retrieval, and agent-to-agent message is immutably logged in real time. If the system detects behavioral drift, alarms trigger instantly, freezing the process. Finally, if the risk agent decides to approve or reject the $10 million loan, it must pass through a programmatic policy enforcement gateway. These are hard-coded deterministic rules where the system sees an AI attempting to make a high-stakes financial decision and it blocks it from executing it. Instead, it shifts to a human-in-the-loop state. It is now up to the human expert to manually hit approve or override. We've barely scratched the surface of how you move from a fragile AI demo to a reliable enterprise-grade system. Looking at this architecture, you might think that building all these memory states, routing layers, and security gateways from scratch sounds like an absolute nightmare. And you would be right. That's why in my next video, I'm going to show you how you can implement such multi-agent architecture without building it from the ground up. Please subscribe to the channel so you don't miss it, and I'll see you in the next one.